So let's see the part 2, right? So part 2 of some basic concept of organic chemistry. Organic chemistry. Right. So question number 5, see, which of the following organic compound has same hybridization as its CO2? Right. So it's talking about CO2 hybridization. Hybridization. So as we know, oxygen having 6 electrons in last orbit and carbon having 4 electrons in the last orbits. So there are total 2 atom of oxygen is there. So this will do the bonding, right? So it will share the electrons. So oxygen has completed its octet. In the similar manner, this oxygen atom has completed its octet, right? In the similar manner, carbon has also completed its octet. So carbon has made double bond with oxygen and with another atom of oxygen also. So as earlier I have told that when they are double bonds, so one will be sigma and another will be pi bond, right? So sigma bond is counted only for hybridization. Sigma bond is count for hybridization. Hybridization. So there are total 4 bonds. So 2 bonds is pi bond. So pi bond will not counted. So in sp3, we'll neglect two bonds, right? So s, px, py, pz is there, right? This is Z. So this will form the pi bond and this will form the sigma bond, right? So hybridization will be for carbon. CO2 will be sp only. So this is the hybridization for CO2. In the similar manner, we have to find in the options, right? So first option is ethane. So ethane is nothing but it is C2H6, right? It is coming from alkane family. Alkane general formula is CnH2n plus 2. So when we put 2, you will get C2H6, right? So in alkane, single bond is there. So it will make the all single bonds. So carbon is here sp3 hybridized. So this option is not valid. So let's see the second option, right? Second is ethyne. Ethyne. So as we know, ethane comes from alkyne family. So its general formula is nothing but it is CnH2n minus of 2. So it is making triple bond. So in alkyne, carbon makes triple bond, right? So here it is sigma, it is pi, it is pi. So 2 pi bond is there, right? So it will make only sigma bond, sp bond. And last px and pz is making this is py, this is px, right? So this will make the pi bond. So hybridization of this will be for ethane will be sp. So this will be the answer, B option. So it is asked in 2014. Please write it down. Now look at the question number 6. So the radical, so benzene compound is there with the 6 carbon atom with alternate pi bond, right? So it is CH2 free radical. This is your free radical. When one dot means one electron is there. So this is called free radical. Is aromatic because it has. So it is aromatic compound. Aromatic compound. So how will you identify aromatics? It should be alternate pi bond, right? It should be alternate pi bond, right? And Each carbon is sp2 hybridized. So you can see here this carbon is making 4 bond and each carbon has one hydrogen atom, right? So suppose I am talking about this carbon. So it is making 1, 2, 3, 4 bond. Out of four, one is pi bond and other rest of the others are sigma bonds. So three sigma, right? And one pi. So last PZ will be forming in pi bond, forming pi bond, right? So hybridization will be sp2. So each carbon in benzene is forming sp2 hybridization, right? So it is asked in 2016. So aromatic be what? Because of what? So see here, as we know, this is benzyl free radical. Its name is also called as benzyl free radical. Is aromatic as per Huckel's rule. So who gives this rule? Given by the scientist Huckel's. Huckel's rule. Huckel's rule. It has 6 pi electron. So how will you count the pi electron? Again, I am drawing this structure, right? So there is alternate pi bond. So you can count the number of electron. 1, 2, 3, 4, 5, 6. So total 6 pi electrons are there. Electrons are there, right? Present in p orbital of carbon. So this is forming the pi bond, right? So pi bond is present in p orbital. So right here also it is present in p orbital, right? So here six orbital and six paired unpaired electrons are there. So it is total six now. So Huckel's rule formula is plus 2n plus pi electrons should be there. So when we put n equal to 1, you will get 6 pi electrons. This is also 2. So it is 2n plus 2 pi. 2 plus 2. It will become 4. Right. So please correct this formula, Huckel's rule. So it is not this one. It is 4n plus 2 pi electrons. That is 4n plus 4n, right? 4n plus 2, right? Pi electrons. So when we put n equal to 1 here, suppose 4 into 1 plus 2 into pi. So it will be 4 plus 2. That is equal to 6 pi, right? So total 6 pi electrons are there. So n should be 1, 2, 3, 4, 5. So when suppose two benzene rings are there, when we put n equal to 2, so it will be 4 into 2 plus 2 pi electrons. So it will be 8 plus 2, that is 10 pi electrons should be there, right? Two benzene rings you can form like this. Alternate pi bond is there. So you can count the number of electrons by your own also. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is coming out to be 10, right? So it is satisfying the Huckel's rule. So it is also your aromatic compounds, right? So in this way we can find aromatic compounds. So aromatic compounds should satisfy the two conditions. Each carbon should be sp2 hybridized and it should be the multiple of 4n plus 2 pi electrons. So please write the answer. Now see the next term, that is 7. The structure of isobutyl group. Isobutyl group. Met, eth, prop, but. So total 4 carbons are there in butyl, right? So I will make here C. Why? Iso is there. So in second carbon, one branching is there. Isobutyl group in organic compound is. So you have to see one by one. So iso means one, right? Isobutyl. Isobutyl group. Iso means one and methyl group is present in the side chain and thus the structure should be isobutyl. So this is the isobutyl structure. So this should satisfy like this, right? And this will be HH. So this branching is isobutyl. So there should be another R connection should be there, but this should be fixed. So this part is fixed for isobutyl. So you can see it is where it is present. So it is present in first option only, right? So answer will be first. So first option is looking like this: CH3, C, CH3, H, CH2, right? So you can just check it out. It is same as this one, right? Two methyl group is there. So here two methyl groups are there. So there is CH bond. So this is your CH bond, and this is your CH2. So this is your CH2, right? So first option will be coming out. It is asked in 2013 in Neet. Now see the question number 8. Which nomenclature is not according to IUPAC system? So compounds are given. So you will see the first I will draw the structure, then I will write the name. Then you have to tell is it according to IUPAC name or not. So BrCH2 CH double bond CH2. So it is written 1 bromo probe 2 in probe 2 in. So is it correct or wrong? So in IUPAC nomenclature, preference is given to multiple bond than halogen. So here we have counted from this, right? From left hand side, left to right, left to right. But it is actually, but first we give the most preference to the double bond. So counting should be from here, 1, 2, 3, 4. So then name change to the this one. So it will be 3 bromo, right? 3 bromo methyl probe. So it will be probe 1 in, right? So it is not following the IUPAC rule. So write the here double bond is given more preference. Preference than halogen. Right. So this will be the name of that. And this is found we have right incorrect. So rest will be the right one. So first option is your answer of that one. Now see the question number 9. The correct order of increasing bond length. So some bond length is given CH, CO, CC, and C double bond C. Right. So this is the correct order of increasing bond length. You have to just arrange the increasing order. So it is asked in 2011. So let's see the explanation. Bond lengths are given. So I will write the this value. So it is 0.109 picometer. CC double bond is 0.134 picometer. Unit will be same. And CO bond is 0.143 picometer. Next is CC, that is 0.154. So you can just observe by looking at the number. So whose value is less, right? CH bond length is smaller, right? So this is coming at a least position, right? Next, increasing is after 109, it is 134. So CC bond is more bigger than CH bond. Next is CO bond. Next is CC bond. So this will be the increasing order, right? So increasing bond order. Please write it down.
Done, sir.
Okay. So let's see the next sum. That is 10. 10 is the priority order is doubled. So see, 10th is given as, first I will draw the structure. It is like this. So you have to just correct the IUPAC name. It is asked in 2011. So priority double bond is greater, right, than single bond. So right here, priority order. Double bond is more priority than single bond. So see here, it is 1, 2, 3, 4, 5, 6. So see the longest chain, right? So this is your longest, and this will come in the branching, this part. So 6 are there, so it will be hex 1 in. Hex 1 in. Right, at first carbon double bond is there. So third is at your branching. So it will be 1, 2, 3. And next at fourth, it is 1, 2. So 3 means methith pro. So it will be propyl. Right. So there is 3 propyl. And next is 4. So it is 4 ethyl group is there. So it is 2 carbon is called ethyl. So it will be 4 ethyl, 3 propyl, hex 1 in. So this will be the answer for that. Write it down. Done.
Yes, sir.
Okay. Now see the next sum. So IUPAC name of the compound. So it is given CH triple bond C CH double bond CH2. So it is asking the name of it, right? So double bond has the preference over triple bond. So double bond is always given more preference. Double bond is more value than triple bond. So while naming the organic compound. So right. So we'll start from on right hand side. Double bond is from there only, right? So it is 1, 2, 3, 4. 4 carbons are there, right? So it is but 1 in 3 ion. So it will be but 1 in 3 ion, right? Or it can be written as like this also. It is 1 but in 3 ion. So you will find more written in this form only. This can be also written. So please write it down. Let's see the question number 12. The state of hybridization of C2, C2, C3, C5 and C6 are given. So I will draw the structure. So it is CH3, C, CH3, CH3, CH double bond, CH. So it is CH, right? So it is CH3. Named is given third. Next is C triple bond CH. So it is 1, 2, 3, 4, 5, 6, 7. So a state of hybridization it is asking about, right, of each carbon, suppose. So I will explain. So first carbon is making triple bond. So as I have told earlier that when it is making triple bond, sp hybridization will be there. And when double bond is there, it will be sp2. And single bond is there, then it is sp3. So follow this rule and you will get the answer directly, right? So you can see first carbon is making triple bond. So it will be sp, right? In the similar manner, second will be also sp. So now see the third one. Third one is making every with the single bond. So it will be sp3 each atom, right? Now fourth. So it is double bond. So it will be sp2 hybridization. Next is fifth. So it is also making double bond. So it will be sp2. Now look at the sixth. It is making single bond with each carbon. So it will be sp3. And seventh is also sp3 because it is also making single bond with another atom of hydrogen. So write the hybridization state of each carbon. It is asked in 2009. Now see the question number 13. The hybridization of CH3, CH, double bond CH, CH2, C, triple bond CH. Counting is given 1, 2, 3, 4, 5, 6. So it is talking about the hybridization only. So very simple to solve, right? First one is triple bond. So it is sp. Second one is also triple. So it is also sp. This is all are looking at single. So it will be sp3. This is making double bond, right? So it will be sp2. This is also double bond. It is sp2. Next is it is single bond. So it will be sp3 hybridization. Right. So write it out. It is asked in 2008. Done. Next is correct order regarding the electronegativity. So next one is regarding electronegativity of hybrid orbital. So just remember the sequence. It is asked in 2014. So there are three types of hybridization I have told you, like sp3, sp2, and sp. So correct order regarding the electronic configuration, electronegativity of will be sp, right? Why it is so, I will explain it now. So in sp, so when it is 100%, right? So contribution is 1s plus 1p. So 50% is contribution given by s and 50% is given by p. So this is your s, this is your p. So which is due to the increase in S character. S character increases electron attracted tendency. So why it is so? Because S orbital character, it increase electron attracting tendency. Right. So electronegativity increases. So due to this electronegativity, negativity increases. So in SP, S character is 50%, right? So this will be the first or highest electronegativity. Then least will be sp3, right? Because P character increases now. That's why. So please write this order and remember it. It will be asked in your exam. So let's see the next sum, that is 15. So IUPAC name of this compound. So I will make the diagram first or structure. So this is the structure given to you. So you have to write the IUPAC name. It is asked in 2006. Asked in 2006. So look at the explanation. So first preference is given from first this carbon. So this is the first, right? Next one is second, third, fourth, fifth. So we'll see the longest chain. So longest chain is of the fifth carbon. So you can see on second and third there is branching. So this is your branching and this is your also branching. So it is nothing but it is CH3. This is your CH3, right? And this will be the suffix coming out to be. So it is 2 comma 3, right? 2 and 3 carrying out methyl group. So it is dimethyl pent. So it is your pentanoyl chloride. Pentanoyl chloride. So it is coming out to be this family like R C double bond O Cl. So its common name is acyl chloride. So I have used here chloride, right? But instead of acyl, there is pent. 5 carbons are there. So I have written pent, oil chloride. Oil for C double bond O and chloride for Cl, right? And this is your branching. So first write the branching, right? Why 2? Because same methyl group is attached with 2 and 3. So this is the diamonds 2. So this is the IUPAC name of this compound. Done?
Yes, sir.
Okay. Now see the next sum. 16. Name of some compounds are given. Which one is not the correct name in IUPAC system? It is asked in 2005. Name of some compounds are given which is not correct about the IUPAC. Right. So see. So first option is given like CH3, CHOH. It is CH. Here CH3. It is CH3. So name of this compound is given like 3-methyl 2-butanol. Right. So counting is started from here. 1, 2, 3, 4. Right. So this is coming out to be at second position. So these two should be written here. So it is not correct. So it is talking about name the compounds given which one is not the correct. Not correct. So it is correct one, right? So 2 can be written here and outside also. This is correct, right? So next C. Next is CH3. C triple bond C. CH. Here 2 methyl groups